Ever wondered how fast something is changing at a precise moment? We will learn differentiation, a calculus tool to find instantaneous rates of change. We will define it, explore derivatives, learn basic rules, and see real-world uses. Differentiation is a method in calculus. It helps us find the exact rate at which one quantity changes with respect to another. The result of differentiation is called the derivative. Imagine a curve on a graph representing a changing value. The derivative at any point on this curve is the slope of the tangent line. A tangent line is a straight line that just touches the curve at that single point, matching its steepness. This tangent line's slope tells us the instantaneous rate of change right at that specific point. Let's learn our first differentiation rule, the power rule. For a function like x to the power of n, its derivative is n times x to the power of n minus 1. For example, if we differentiate x squared, we get 2x to the power of 1, or simply 2x. Next, consider the constant rule. If you differentiate a constant number, like 5, its derivative is always 0. This makes sense because a constant value does not change. The sum and difference rule helps with more complex functions. This rule says you can differentiate each term of a function separately. Then, you just add or subtract the derivatives of those individual terms. Differentiation has many practical uses, like understanding how quickly things move. If a function describes an object's distance over time, its derivative tells us the object's instantaneous velocity. Let's use an example. A ball's height is described by the function h of t equals 5 minus t squared. Its derivative is minus 2t. This tells us the ball's instantaneous vertical velocity at any time t. Differentiation also helps us find maximum or minimum values, which is called optimization. For instance, how would you find the exact time the ball in our example reaches its highest point? At the highest point, the ball's vertical velocity, which is its derivative, momentarily becomes 0. By setting the derivative, minus 2t, equal to 0, we find the precise time when the ball is at its peak. Today, we learned that differentiation finds exact instantaneous rates of change. We saw how a derivative represents the slope of a tangent line on a graph. We covered basic rules like the power rule, constant rule, and sum and difference rule. We also saw differentiation's power in understanding velocity and optimizing scenarios. Keep exploring how this fundamental tool helps us analyze and predict changes in our dynamic world. Generate your own educational videos for free at eduvids.vercel.app.